Hello everyone, my name is Meng Yan. I'm from Chongqing University, China. Today I'm very glad to share our IMS paper, Characterizing and Identify Reverted Commits. What if you discover a problematic commit? A problematic commit may be a commit to introduce defect, technical debt, or implement an unnecessary feature. Usually, a developer may consider to fix it. However, there's another solution is to revert it. Reverting is a coarse-grained approach for recovering from a problematic commit. Here are an example of a reverted and reverting commits in H-based project. The left commit is a reverting commit, which is submitted in September 2017. This commit, from the commit log of this commit, we can find that this commit revert another commit, and we can identify the commit ID of the reverted commit. The reverted commit is the commit in the right side. This commit was submitted in April 2016. What is the impact of reverting a commit? Suppose here are two commits, commit 1 and commit 2. Commit 2 is the reverting commit, which reverses commit 1. And in commit 1, it changes the file A to file A plus, and in commit 2, it changes A plus change back to file A. And the commit 1 from the commit 1, the reverted commit of the commit 1 may linger for a long time in the project. So this will bring some problems, such as developer may be confused about should I update other related code which is related to the file A? And if so, what is the context of the commit 1? How can I change? How can I update the other related code? This may take a long time to call back the context of the commit 1. So the impact of the reverting commit is it will increase the difficulty of software maintenance, and it will invade the development progress. So our motivation is that what are the characteristics of the reverted commits, and can we identify reverted commits just in time? If so, we can bring some benefits, such as we can help to understand the reverted commits from different dimensions or features. And we can inform developers just in time about which commit will likely to be reverted in the future. And we can perform an early detection or fixing of problematic commit. To address this question, we proposed an automatic approach. First, we will extract some the historical changes from the Git history, and we will label it as reverted or not by checking the commit log and change the content of the code. And then we will extract different dimensional features. In total, we extract 27 commit features from 3 dimensions. Then we will use a random forest model to build a classification model. This is our model building phase. In our model application phase, when a new commit is submitted, the build model will identify it as reverted or not just in time. To evaluate our approach, we designed 3 research questions. In RK1, we investigated the performance of our approach and baselines. As a result, we found that our model can achieve promised AUC and cost effectiveness, and can improve for baseline by a substantial margin with a statistical significance and a large effect size. In RK2, we investigated the performance of different dimensional features. As a result, we found that developer is the most discriminative dimension. However, using all dimensional features is better. In RK3, we investigated the feature importance. As a result, we identified some important features for identifying reverted commits, such as the lines of code added and deleted, and the experiments features. are the most discriminative features for identifying reverted commits. Finally, we provided some implications for both practitioners and researchers. For practitioners, the analysis and handling of reverted commits cannot be ignored, because in our dataset we found that around 2.5% of commits are reverted, and they may link for as long as 800 days. And developers should pay more attention to the commits made by these experienced developers, because the commits submitted by them they are more likely to be reverted. And for researchers, the labeling method for reverted commits should be reverted. We cannot only rely on the commit block. We should also focus on the change content of the change files. And further research for enhancing the performance can pay more attention on features of developer and change dimensions. Summary: in this paper, we highlighted the problem of change level reverted identification, and we propose a model by using 27 commit features. And our model can achieve a promised AUC and cost effectively on 10 projects. Finally, we provide some implications for both practitioners and research on reverted commits. Thank you.